Hi guys, let's take a look at this question where we have trolley X of mass 1.2 kgs that's traveling at 8 meters per second e, so to the right. So that's the initial velocity. And it collides with trolley Y of mass 0.5 kgs, which is initially at rest. So initial velocity of trolley Y is 0. They give us the velocity versus time graph here for trolley X only, before, during, and after the collision. Very important, guys, that there's a mistake on this. It's going to be 0, the time, 0.1, and 0.2, not 20.1, etc. 4.1, state the principle of conservation of linear momentum. So that is, in an isolated system, the total momentum or linear momentum is conserved or remains constant. 4.2, calculate the magnitude of the velocity of trolley Y immediately after the collision. So what can we do here, guys? We can use our trusty formula, the mass of trolley X, the initial velocity of trolley X plus the mass of trolley Y times the initial velocity of trolley Y is going to be equal to the mass of trolley X times the final velocity of trolley X plus mass of trolley Y times the final velocity of trolley Y. And we're going to insert our values right now. So the mass of trolley Y is 1.2 and the mass of trolley X is 1.2 and trolley Y is 0.5. So this is going to be 1.2. Initial velocity of trolley X has been given as 8 meters per second. So it's going to be 8. Trolley Y is 0.5 mass and the initial velocity, it starts at rest. So the initial velocity has to be 0. Then the mass again of trolley X is 1.2. The final velocity, do we see here? They actually give it on the graph. They give before, during, and after the collision. And so final velocity will be 4. Then again, the mass is 0.5 and the final velocity is what we want, right? Of trolley Y. So anything times 0 is 0. So we multiply that. We divide everything by 0.5 to get our final velocity alone. And that is going to be 9.6 meters per second. That's the velocity of trolley Y immediately after the collision. Then 4.2.2, we want the average net force that trolley X exerts on trolley Y during the collision. All right, so we want the net force, which we're going to use this formula for. I'll just show you on the formula sheet. It's that one right there. So we want the average net force. We want it during the collision. So this is going to be during the collision, right? So that's going to be the time of 0.1. So our net force is going to be times 0.1. And remember, what does the P stand for? Is that? So I'm just going to rewrite it. And that's going to be mass final velocity minus initial velocity. Remember, I just said that's going to be 0.1 because that is going to be during the collision. The mass is going to be 1.2 of X. The final velocity is 4. Initial velocity is 8. I'll just re-show you again. So it's going to be 4 minus 8. Then we get our net force. We do our math magic and we get negative 48 newtons, which you can then equate to 48 newtons. All right. They did want the magnitude, so you don't have to write any direction. So I just want to inform you that I took east as positive in this question. So I took to the right as positive. Okay. Then 4.3, is the collision elastic or inelastic? Explain the answer by means of a suitable calculation. So how would we explain something like this? Using a calculation. So the easiest way to go about doing this is to calculate the sum of the kinetic energies before of both trolleys and the sum of the kinetic energies after the collision. And if they are the same, then it's elastic. And if they are not the same, it is inelastic. All right, so let's try that. I'm just going to erase everything on this slide so I can have a nice clean slide. Okay, so 4.3, I'm going to have the sum of the kinetic energy before the collision. So you can literally write before collision there if you want to, before collision. So it's going to be, so you can write the X there if you want, just to show the examiner this is the X and this is the Y. So before the collision, the mass of X is 1.2 and the initial velocity is 8 squared. we know that, sorry, that's going to be a plus. We know that y starts at a rest, so initial velocity is 0. So anything multiplied by 0 will be 0. So our answer will then be 38, 4. So 38,4 joules. And then the sum of the kinetic energy after the collision. So you'll do the exact same thing, same formula. I like to write my formulas just so you like anchoring yourself almost. So you know exactly what you have to do, where you have to put in your values, right? So it's going to again be half 1.2 initial velocity. Well, this is going to be final velocity, not initial velocity, final velocity. We remember that our final velocity of our x is 4, and the final velocity of our trolley y, we've just calculated that in the previous question, and that was 9.6, and we square that, and we put that all into the calculator, and we get 32,64 joules. Now, 38,4 and 32,64, they are not the same. So, the sum of kinetic energy before the collision is not the same as the sum of the kinetic energy after collision. And therefore, it's inelastic. The collision was inelastic because they are not the same. All right. And that's it, guys. See ya.